Hi students, welcome to our class DYA 10013 Soil Science. Soil fertility and management. Okay, when we talk about soil fertility, fertilizers, nutrients. So when explained in previous chapters, although the soil have a lot of nutrients, but there are some limitations in soil. So that's why we have total fertilizer and also available fertilizer, especially for nitrogen and also phosphorus. NPK, both all the three NPKs, they will have total nitrogen. We have to calculate the total nitrogen and also available nitrogen. Same goes to phosphorus and also potassium. These limiting factors due to the range in soil pH. Normally, total nutrient content, total nitrogen, total phosphorus, total potassium, we will get the data from soil analysis, similar to the soil sample that you all took during the lab 1, that we use auger, right? So we have to analyze this from 0 to 50. We took soil samples from 0 to underneath the soil up to 15 cm. There are a lot of other soil testings that we have to do if it's required, like we have to do from 15 cm to beneath soil up to 60 cm. That one we have plenty of other micronutrient testings that we can do using that B sample from 15 to 30 cm. So for nitrogen, total NPKs we can test using soil testing sample. While available means although we have the soil is rich in nutrients, but plant uptake, there is a factor that limited the plant uptake of nutrients. So we will do leaf samplings and analyze the nitrogen, the phosphorus, the potassium content in the leaf. That data we will call it as available nitrogen, available phosphorus, available potassium. So by doing both nutrient testings, we can conclude that the soil is rich in nutrient, but there are some limiting factors that inhibit the plant uptake of nutrients. So one of the factors that become limiting factors for plant uptake of the nutrients is pH. If the pH of the soil is between 5.5 to 6.5, almost all the nutrients and also micronutrients as well is easily uptaken by plants. While if the pH of the soil becomes a bit acidic or slightly acidic, so even though the soil is rich with nutrients, the plant cannot uptake the nutrient. So one of the way to increase the soil pH is liming. So there are plenty of products in market like calcium carbonate. Calcium carbonate is very familiar type of lime available in the market, available in Malaysia. We can apply gypsum, even magnesium silicate, magnesium sulfate. These type of products we can use to alter soil pH, not only focus on calcium carbonate. If you don't have calcium carbonate, we can change to other products like magnesium silicate, magnesium sulfate. Okay, application of lime of acid soil to achieve suitable pH. So for us, our suitable pH will be between the range of 5.5 to 6.5. So don't stick with this, the suitable pH is 6.5. The suitable pH is 6. It's wrong. We cannot maintain the pH in, so that's why we put in range. And sometimes some type of plants, it depends on the plants. Some plants need acidic soil. For example, oil palm. Oil palm can survive, or they need a pH around 5 to 5.5. Or for ananas means nanas. For pineapples, they need pH, they can survive, or they need pH between 4.5 to 5.5. So this kind of crops, they need acidic soil. So we have to do, in order to analyze, before we plant something, we have to do soil analysis. Before you use the soil, in your case, your aqua students, so before you cultivate, before you want to do something with the soil, you have to do soil analysis, especially the soil pH. If you want to do column, right? Column fish pond, you have to maintain the pH of the fish pond between the range of 5.5 to even 7.5. Depends on what type of fish you are rearing, or either fish or prawn or even aquatic grasses, algae. So it's you have to play around with the pH. Don't simply throw the fertilizer in the pond. Don't simply apply. You have to test the soil first. If the soil is in the suitable range, you don't need to waste your money and applying the lime. It's wrong practice. Don't waste your money. Don't waste the resources available. So why do we need to do liming? Acidity in soil is because hydrogen. The more the H plus, the more acidic. The lesser the soil, the pH value of the soil. So let's say when I take two water samples. If water sample A shows there are about 10 H plus, compared with water samples B that have a 50 H plus. So that shows the acidity level of B is higher compared with sample A, because sample A only have 10 while sample B have 50 H plus. We call it as strong acid, while the B sample will be less acidic or more to neutral. So acidity mainly because of H plus and also aluminium. Aluminium cations are present for soil acidity. This is what happened when a simple story. A estate in Batu Bahat, Johor. They called me. They said their soil. They have planted oil palm. It's already 4 years, but they cannot see any growth. So I go and have a visit, because last time I worked as an agronomist, so I give a visit to the estate. When I study the pH strength of the estate, the water source, the pH of the water source is 6.5, very suitable, very nice at the top of the hill. It's passed by the route to reach the destination is about 8 kilometers. In between, they pass by big ponds, they pass by peat areas and acid sulfate area. By the time they reach the acid sulfate area, the pH level dropped to 2.3. It's filthy acidic. Now just imagine the initial water source, the pH level of initial water source is 6.5 and they drop up to 2.3 after the water travel to about 8 kilometers. This is due to aluminium present in the soil, as well as they bypass the peat area. Other sources of acidity in soil, yes, as I explained just now, because of OM decomposition, where organic material are present in peat soil. So other sources will be like leaching of basic cations from soil surface due to erosions, due to water leach out, water run off on the top of the soil. Uptake of basic cations by plants. Once plants uptake nutrients, cations here means nutrients, the elements, all the elements, N, P, K, magnesium, sulfate, chlorine, sulfur, manganese, molybdenum, boron, zinc, ferrum, whatever the 17 essential elements, right? All the 17 essential elements are cations. So once plants uptake the cations, the cation exchange site in colloid will be empty. So who will fill up the empty layers, empty room, empty space? H plus. I explained this in our second chapter, soil physical properties, soil chemical properties. When I explained about CEC, I did explain about this. Usually it will fill up by nutrients, cations, and also H plus. Once the cations uptake by plants, H plus, readily available H plus in the soil surface, in the soil will absorb or will fill up the holes in colloid. So once colloid are full with or rich with H plus, it will become acidic. So one of the way for us to change the H plus is to apply more cations. So like when we apply magnesium are 2 plus. The iron present in magnesium is 2 plus. That's why we apply magnesium based cations, magnesium based lime. Or when we apply calcium carbonate, they have 2 plus. That's why we apply calcium based cations. So they have 2 plus, more charges still. So they have to release 2 H plus in order to enter, to attach with the colloid. So easily, very fast, the soil pH will increase. We can apply N plus, we can apply P plus, K plus, but it will cost you because it take more. In order to remove 2 H plus, you have to apply 2 N. While when you apply 1 N, it will automatically remove 2 H plus and replace that area. Importance of liming. Why we have to apply lime? Of course, the first reason is to change the soil pH, to increase the soil pH. pH range between 5.5 to 7. Increase P availability. This one I explained in the initial part of this video. We have total N, total P, total K, as well as available P, available N, available K. So to increase the P availability, to reduce toxicity in soil, as well as this one, you can say to supply calcium, to supply magnesium as well. Does it depend on what type of lime that we apply in the soil? So example here, last time, yes, calcium based limes are cheap. That's why we apply calcium based lime. Now magnesium based limes also are cheaper compared with calcium carbonate. So why not we can apply magnesium based lime. It supply magnesium as well as it's alter the pH of the soil. This is the one that I explained just now here regarding how the H plus attach with our colloid layers, and when we apply our cations, the cations will remove the H plus and attach here, attach in the colloid. Remember, clay is colloid for mineral soil. Correcting soil acidity is costly. It will take a lot of time, a lot of money as well. So these are, I will explain about this in our next video. We have about 20 more slides to go to finish this chapter 3. Okay, thank you class, enjoy your day, bye.